Have you ever wondered why modern AI projects run perfectly in development, CI/CD, and production without breaking? How do large-scale AI platforms manage thousands of libraries, exact versions, security checks, and instant deployments? The answer is package managers. A package manager is not just a tool that installs libraries. It is the system that makes your applications reproducible, scalable, secure, and production-ready. In today's video, we're going to break down what a package manager really does, why dependency resolution is critical, how lock files guarantee identical builds, version pinning strategies, security scanning, registry ecosystem, and finally, how NPM powers real-world AI applications with practical workflows. Let's start from the foundation. What is a package manager? A package manager automates the complete lifecycle of software dependencies. It helps you discover packages, download them, install them, upgrade or downgrade, manage versions, and remove unused libraries. In modern AI and cloud engineering, every layer has its own package manager. Front-end, NPM, Python AI services, pip, GPU environments, Conda, containers, Docker, Kubernetes, Helm, infrastructure, Terraform. Without package managers, building a reproducible AI platform is impossible. Dependency resolution. When you install one library, it depends on many other libraries. These are called transitive dependencies. A package manager automatically finds the correct compatible versions and resolves conflicts, so your project works without manual effort. Reproducible builds. In production, we need the same build everywhere. That's where lock files come in. package-lock.json, requirements.txt, chart.lock. These files pin every dependency to an exact version, which means your application runs identically in development, CI/CD, and production. No surprises. No, it works on my machine problems. Lifecycle management. With a single command, you can install packages, upgrade them, downgrade them, remove them, and the dependency graph stays consistent automatically. This is critical for fast-moving AI platforms. Version pinning strategy. In development, version ranges for flexibility. In production, exact versions for stability. This simple strategy prevents unexpected failures after deployment. Security scanning. Modern package managers also protect your applications. Tools like npm audit, pip.audit, gripe.trivy scan your dependencies for known vulnerabilities before they reach production. This is a core part of DevSecOps in AI systems. Registry ecosystem. Every package manager connects to a central registry, Python to PyPI, Node.js to NPM registry, containers to Docker Hub. In enterprises, private registries like Amazon ECR, Azure Container Registry, Sonatype Nexus are used to store internal packages securely. So now you understand, package managers are not just installation tools. They are the foundation of reproducible, scalable, and secure AI platforms. If you want to become an AI engineer, cloud engineer, or DevOps professional, this is a concept you must master. In the next video, we'll go deeper into how NPM powers real-world AI applications with practical workflows. Until then, keep learning, keep building, and keep growing.